Welcome all. Today I would like to show you a gravitational energy dam which is situated at the north side of famous Black Forest in Germany or Schwarzwald. The dam is known as Schwarzenbach-Talsperre. So what makes this dam so special is the structure and its design. It's a water dam that is used to produce the electricity. But unlike the other water dams, its design is super clever and extremely intelligent. Later I will show you in detail how it works and what makes it a genius design. Also in my other videos, I will try to explain that this dam is a smaller part of the whole ecosystem that Germany has built cleverly, not only to use water to produce electricity, but also to form and build its rivers and related industries. Like I said, it's a whole ecosystem where it has subsystems to use the water clever as possible as they can. This dam was built between 1922 to 1926 and it is a small network of dams and water storage system for the Forbach and Murgtal areas of North Black Forest side in Germany. The dam originally constructed by Rudolf-Fettweis-Werk and now it's operated by the EnBW Energy Company of Germany. The dam uses a high-performance pumped storage power plant technology. It also called pumped storage hydroelectricity PHS system, which is normally used as a load balancing system. But if in a place where more rain and snow water can be stored, like most of the northern areas in Pakistan has higher elevation and natural water available, then this is the most effective and clever dam design to produce even cheaper and clean electricity for a longer period of time with the less amount of water. The dam uses two steps to produce the electricity. In step 1, water is stored in the dam. At the bottom of the dam, water pipe is used to release the water. Due to the dam's higher elevation and smaller opening of the pipe at the bottom, the water inside the tank uses gravity as force to build a tremendous amount of pressure, which then released through a smaller diameter pipe. In other words, less amount of water is released against the huge pressure built by the mass of water inside the dam's water tank. In step 2, the released water gets pushed in a smaller diameter pipe that goes to 1.7 kilometer down from an elevation of 600 meters to 300 meters. So this second step gives more gravitational push to the water to increase pressure and speed. Then the amplified water pressure is used to run the turbines and generators to produce the electricity. With this type of design, we use rather less amount of water than we usually use in a regular water dam in Pakistan and gets more force, which gives us more electricity per cubic meter water. In more precise words, this dam stores energy as gravitational force, which then uses gravity force to convert the water's kinetic and potential energy into electricity with the help of turbines. So the lake that stores the water has an area of 400 meters in width, 65 meters in height, and 2 kilometers in length. It is 668 meters above the sea level. The lake can store up to 14.4 million cubic meter water and can produce around 6,542 megawatt hour total energy. If bottom outlet or pipes are used to produce the energy, then it will take 2.5 months to empty the whole tank. Or in other words, it can produce electricity for 2.5 months continuously without getting extra water. The dam has capacity to produce around 44 megawatt hour electricity. The electricity is actually produced in Forbach, which is around 1.7 kilometers far from Schwarzenbach Dam. So dam does not have any turbines or generators. Its sole purpose is to store water like a water tank. So again, the dam has a height of 65 meters at an elevation of 665 meters, whereas the water pipe opening that carries the water starts at the bottom around 600 meters elevation. But the turbines and generators are further down in Forbach, which is at 300 meters elevation, and this is where the actual electricity is produced. So the dam uses the gravity as force, and this force further gets amplified with the smaller pipe openings, and even further with 300 meters lesser elevation allows more gravitational force to achieve the maximum pressure to run the turbines. Also, on the top of the wall there are 24 open gates for overflow, which then gets dropped into the surface canal, which then is linked to the main water gathering canal or Murg river. In Germany and other parts of the world, this type of dam is used for load balancing to manage the electricity needs. Apart from visiting the dam and studying its clever design, the Schwarzenbach Valley offers quite a few recreational activities. There is a natural park inside the Black Forest, which is great for hiking. Also, there are opportunities for boating, fishing, swimming, and windsurfing. In winter, the neighboring areas offers whole bunch of skiing possibilities as well. And it is a very beautiful mountain terrain full of natural beauty. Just for the reference, Pakistan's Tarbela Dam has a surface area of approximately 250 square kilometers. It is 470 meters above from the sea level, so its total capacity was around 13.7 cubic kilometers, and due to the silting process, now it's 8.4 cubic kilometers. Tarbela Dam has an area of 2,743 meters in width, 143 meters in height, 80 kilometers in length, and its current total capacity is 4,888 megawatt hour. Importantly, annually over 70% of water is discharged for irrigation and only 30% is used to produce the electricity. So here is more of a comparison between Germany's and Pakistan's dam. I'm comparing Germany's Schwarzenbach Dam with the Tarbela Dam in Pakistan and Diamir Bhasha Dam in Pakistan. So Tarbela Dam is the world's largest fill-type dam. From the design point of view, Schwarzenbach Dam is a gravity dam with high-performance PHS system. Tarbela Dam is a spillway design and Diamir Bhasha Dam is a simple gravity design. The purpose of Schwarzenbach Dam is to produce electricity. The purpose of Tarbela Dam is to produce electricity and provide irrigation water. And the purpose of Diamir Bhasha Dam is to produce electricity as well. Now, if we look at the output capacity, Schwarzenbach Dam has a capacity of 6,542 megawatt hour. Tarbela Dam has a capacity of 4,888 megawatt hour, and the Diamir Bhasha Dam has the capacity of 4,800 megawatt hours. So if we compare the size and water capacities, they are way more different and they don't even match together at all. So the Schwarzenbach Dam is in width 400 meters, 65 meters in height, and 2 kilometers in length, whereas the Tarbela Dam is 2.7 kilometers in width, 143 meters in height, and 80 kilometers long. And if I compare with the Diamir Bhasha Dam, I could not find the width and length data, but it is 272 meters high. So if I pay attention to the technology and the timeline, then the Schwarzenbach Dam is the oldest dam and it is built in 1926, which has original engineering technology developed in 1850s. And if I compare with the Tarbela Dam in Pakistan, that is built in 1976, and the Diamir Bhasha Dam will be finished in 2028. And Schwarzenbach Dam took 4 years to build, and the Tarbela Dam in Pakistan needed more than 10 years to finish. If I compare the construction time of the Amir Pasha Dam, then it will take around 8 to 9 years to finish. Also, I would like to mention that the data I have collected for comparison is 100% correct for the Schwarzenbach Dam, and 90% is okay for the Tarbela Dam because there are different resources telling a bit different stories, and there are also extensions in Tarbela Dam, so which can vary some data as well. In the case of the Amir Pasha Dam, 80% data is okay, 20% is unknown or not mentioned in different websites. And the main takeaway from the whole comparison is that if I compare the capacities, the amount of water each dam holds, and the amount of electricity each dam can produce, is a way huge numbers. If I just compare the length part, the Tabela Dam is 80 kilometers in length, and Schwarzenbach Dam is 2 kilometers in length, which does not match at all. It is 40 times bigger dam, and if I compare the height, Schwarzenbach Dam is only 65 meter in depth and Tarbela Dam is quite a bit. So I think we need to consider our technology analysts who are designing those dams. Also, for the future development in Pakistan, the terrain is way more high in elevation, is rich with snow and rainwater. Also natural water is there. So if we build small to medium size high performance gravity dams there, the whole network of them, it will produce so much energy, and it will solve so many irrigation problems that we are not considering. So I will highly suggest to please look at the video again and spread the words to other people that they should be at least aware what other possibilities are available in the world. And when the people have built them, people are using those technologies since 130 years, and we are not even into the game. Thank you for watching, and please subscribe the channel and spread the video as much as you can. The main purpose is that people should know that no matter where they live on the planet, that there are better technologies to produce the clean and sustainable energy, which then can be used to build the whole ecosystem with the water that we have on the land. Thank you again, and we'll see you in my next videos.